In question 6a, we're told a semiconducting diode is an example of a non-ohmic component. We need to state what is meant by a non-ohmic component. Well, this is one which does not obey Ohm's law, so the current is not directly proportional to potential difference, which basically means it does not have a constant resistance. In B, we're told a filament lamp is also a non-ohmic component. In part 1, we need to add to these axes the current voltage characteristics for a filament lamp. Well, they go something like this. In part 2, we need to state with reference to the current voltage characteristic graph we've just drawn, how the resistance of the lamp changes as the potential difference across it changes. Well, as the potential difference increases, the resistance of the lamp increases. In C, we have a filament lamp with a power rating of 36 watts with a PD of 12 volts. In part 1, we need to find the resistance of the lamp with the PD across its terminals at 12 volts. Well, for this we can use the equation power is potential difference squared over resistance, rearranging for resistance and adding the data given gives a resistance of 4 ohms. In part 2, a student predicts that if the potential difference across the bulb is reduced from 12 to 6 volts, the power rating would reduce to 9 watts. We need to state and explain how in practice the power rating will be slightly different from this value. Well, the lower potential difference would reduce the temperature of the filament lamp, therefore reduce its resistance. This would give a higher power, as although the potential difference had halved, the current would not quite halve.